Good morning, everybody. Happy Wednesday. Last lesson of the unit. We are looking at function notation just a little bit further and looking at functions a bit more. And that's it for new stuff. Okay, we'll wrap this one up, do a little homework, do a little quizzes today, a check for understanding. And then tomorrow I'll throw out some review material and I'll throw out the summative assignment, which is the unit exam, but not a unit exam. And you'll have the whole weekend to do that. And that's it. There's no material posted on Friday. That's a PD day for staff. So I'm just going to throw this stuff to you on Thursday, give you the whole weekend. It's the long weekend too. So we have Monday off. So you have the entire time, and then we'll be moving on to our next unit. So with that said, let's jump into today and get this one done. Page 471, jumping in. And we're going to look at function notation just a little bit more. This is a really short lesson, and then we're actually going to jump ahead in the book and do another example, and then we'll do some homework, and then we'll be done for the unit, aside from a little bit of review. So what we're going to talk about is function notation when it comes to a graph. So yesterday we looked at function notation, and really all it came down to is if I have something like this, f of x equals 3x plus 1, well, pretty much just y equals 3x plus 1, okay? Where I can talk about f of x, that's like the output, that's the y value. And then x, the thing inside the bracket, that's my input. Okay, that's like my normal x value. And really, it's no different. I can talk about all the same things I talked about when it was y equals. I can talk about the same things now that it's f of x equals, right? We can graph it. We can talk about domain and range. We can talk about certain points. We can do all of these things. It's really no different. Okay, so we're just going to explore that a little bit and talk about it. Okay. Note values on the independent variable represent the inputs, and those are the horizontal axis. Yeah, that's normal. That's what we normally do. That's my x values. Values on the dependent variable represent the outputs, and those go vertical. Yeah, that's my y value or my f of x value. Okay, that's my output for sure. So it says, use a graphing calculator to sketch the graph of this function, y equals 3x plus 1. Okay, well, I don't have an f of x button, but I have a y equals button. So what I need to do is swap. Instead of saying my output is f of x in function notation, I call it y, which is normal two-variable relation. That's how I would represent it. It doesn't matter. It's still really the same thing. So I pull up my graphing calculator. I go to y equals. I clear out anything I would have, and I type in y equals 3x plus 1. And I'm going to go zoom 6 for zoom standard. Okay. And there it is. Okay. It's a pretty good window. I can see everything. Normally, I would probably leave it. But just for this question, let's, maybe zoom in a bit and try and consider. So I go to my window. And I'm just going to reduce everything from negative 10 to 10. Let's go negative 5 to 5. Negative 5 to 5 with a step of 1. Negative 5 to 5 with a step of 1. Then I go back to my graph. Yeah, that's pretty good. Okay, let's consider that good enough. I'll go to my little sketch here that they gave me. Okay. And maybe I'll redraw that line. Okay. It just peaks up something like this. Okay, and that's a pretty good sketch. Whenever I ask for a sketch, it doesn't need to be perfect, but what I would hope is that you label your x and y intercepts. And let's do that just for the practice of using my calculator. A y-intercept happens, okay, on the y-axis, that's right here. That happens with an x value of 0, and I can actually type in values, second calc, 1 for value, and I wanted an x value of 0, so I type in 0 and I hit enter. There you go. X is 0, y is 1. So I can go back and I can label that on my sketch. That's a y value of 1. X values or x-intercepts are a little bit harder. I go second calc, and these are called zeros. So I press that. I'm looking for this x-intercept over here. I need to be left of that point. Well, I'm not. I'm to the right of it, so I move my cursor till I'm past it. Say left bound, yep. Now I move back to the other side of it, right bound, yep. Now I make a guess. And that is negative 0.33333333. Maybe I recognize that one as a fraction. That's negative 1/3. Okay, so you could write the decimal if you wanted, but I would probably write it as a fraction. It's easier, -1/3. And that's a pretty good sketch. Okay, if I ever ask you to sketch something, I'll tell you specifically what I want. But in general, it's, yeah, draw the line, show me some x-intercepts and y-intercepts and the important points. Okay, all right, that was a good review of our graphing calculator. Let's go on. In each case, express the relation given in function notation as an equation in two variables. So this is just practicing, hey, here's the one written as a function. Okay, can I write it just using x's and y's or whatever letters? So f of x equals 7x minus 23. Really, all I'm changing is it's not f of x, it's a y. Y equals 7x minus 23. Okay. G of t equals t squared minus 2t plus 35. Maybe I would keep that same variable. So g of t, I'm changing that to y. And I could just leave it all as t's. Maybe it's talking about time. Or maybe you want to change everything the x's. X squared minus 2x plus 35. You're just replacing essentially the name of it. Am I calling it y or am I calling it g of t or f of x or whatever? And the variable doesn't really matter, right? It's whatever variable I want to call it. Okay, going the other way. Here's the relation y equals 11x minus 15. Can I write that in function notation? Yeah, absolutely. I'll change the y to an f of x, and everything else would stay the same. Okay. The graph of the function defined by y equals f of x has the equation y equals 4 minus 3x. Okay, so it's telling me y equals f of x. Y and f of x are the same. So instead of writing y, I'm going to write f of x. And it's just knowing if something is a function, I can write it with this function notation, and I can go back and forth between just using the two variables or using the function notation. But it really doesn't matter. It's just a name. It's just another way to write it, and then I do all the same things. Okay, let's go on. I think this is the last one for this lesson, and then we'll jump ahead a bit to it, but that's okay. It says the graph of the function f is shown. So I see this picture, and it's this weird thing where it kind of goes up and then down and then more down and then over. So I don't even know the equation of this thing. I just have a graph. Okay, that's fine. I want to know some values. It says find f of 5, find f of -2, find f of 4. Okay, well, f of 5, that is telling me I need an input of 5 or an x value of 5. So I go along my x-axis or my input and find that value of 5, and then you say, okay, well, from this dot that I just drew, from this x value of 5, what point on the graph has an x value of 5? And it would be right here, 5, comma, -2. So it's just finding the point on the graph. It's interpolating or extrapolating. Okay, f equals -2. That would be, or f at -2. That would be x is equal to -2. So I kind of backtrack a little bit to -2. And I would have to go up. Okay, that point is -2, comma 3, or your output is 3. So we could do this with the equations if we had them. We could solve algebraically, or we can look at the picture and say, hey, which one of these had an input of -2? Same thing with 4. What had an input of 4? That would be -1. Okay, it says write the ordered pairs. Ordered pairs always go input, output, or x, comma, y. 5, comma, -2, -2, comma, 3, and 4, comma, 1. -1. All right. Now let's go the other way. It says state the values if f of x equals -1. Okay, so what I'm doing now is that's an output. So I actually go along the y-axis to -1, and you say, are there any values where this happens? Yeah, over on the right, I've actually already talked about this point. Okay, x equals 4 gives me an output of -1. F of x equals 3. Okay, well, I go up 1, 2, 3. Oh, there are 2 to the right and to the left. I actually have 2 values. It could be x equals 2 or it could be x equals -2. Those are the two options where you have an output of 3. And x equals 4, one higher. Yeah, same thing. Okay, x equals 1 or x equals -1. Okay. It says use the notation in A to make a statement about the points A and B on the graph. Okay, well, let's go and actually look at those. A, it's green point. It is an input of -5 or an x value -5, and it's up 1. So what I'd say is for the input of -5, f of -5 equals 1. Okay, that's for point A. When you input -5, you get an output of 1. For B, one's on the other side, that's an input of 6, so f of 6 gives me an output of 1, 2, 3 downward, so -3. Fantastic. Okay, so I can talk about all of these points using ordered pairs, using function notation, using the x and y values, all sorts of things. It says write the x and y intercepts of the graph using function notation. Okay, x-intercepts. I guess this point on the very left, and then this point kind of in the middle. There'd be 2 x-intercepts. This one and this one. And what I'm saying is their inputs would give me an output of 0. So f of -6 gives me an output of 0. Or it's the point -6, 0. The other one is f of 1, 2, 3 equals 0. The coordinate point 3, 0. But in this case, I'm writing it as function notation. For the y-intercept, it's the opposite. It's f of 0. I know my input is 0, and the output you get is 5. Okay? The little peak of the mountain, I guess let's call it. That's my y-intercept. Or the point 0, 5. So it's just another way to write the things that we already write. Okay. Complete the following statement. The domain of f, all of my possible x's, my x's go from -6, and then I have a bunch of x's all the way through the middle, all the way to +7. So I'll fill that in from -6 to 7. -6 less than or equal to x less than or equal to 7. The range, well, normally I say range is y such that, but in this case, I'm using function notation, so I'd write f of x such that. My range goes from, my very bottom output would be -4. Then I have a bunch of outputs all the way up to +5. From -4 to +5 for f of x element of the real, or y element of the real. Okay, so I would ask the same thing with just normal x and y's, right? I'd say, hey, tell me some points. Hey, what's the x-intercept? Hey, what's the domain and range? So we can do the same thing. It's just a different way to write it. Okay, a different way to look at it. All right, we're going to jump a couple pages ahead. We're going to 477, and we'll do one more question before I send you on your way to do some homework, do a check for understanding, all of that. Okay, page 477, a little bit ahead. A candle manufacturer found that their long-last candles melted according to the formula h of t equals -2t plus 12, where h is the height of the candle in centimeters after t hours. So here's where my function notation kind of has a name to it. H of t, well, we chose h for height, we chose t for time. So the letters maybe have a bit of significance in terms of the name. Use a graphing calculator to sketch the graph and show it on the grid provided. Okay, go to my graphing calculator, go to y equals, clear out what I had, -2t, well, I can't do t's, but I could do x's, plus 12. And just make sure you use the negative button, not the subtract. Okay, -2x. And I'm going to go zoom 6. I always go zoom standard to start, and then I go, okay, well, is that really the best thing? Or maybe should I change my window? Okay, I always want to see my x and y intercepts, and then I also want to think about context. So in this one, it's the height of a candle after a certain amount of time. So when I think about the time, or I think about the x's, I'm not going to go back to -10. I'm going to go to -1. I don't need the negative times. I just want to see it cross that y-axis. So I go a little bit past 0. Okay. And then all the way to 10. And now I'll go back to my graph. Okay, that's pretty good. Okay. I start at 0 and I go this way and I actually see it cross 0. So I'm good. Now let's think about the heights. I'm going to get rid of the negative heights as well, because once this candle burns out, it's done. It hits the height of 0 and I'm good. But I am going to extend it up a little bit because I can't see this y-intercept. So I go to my window. The minimum, -1. I would make it 0, but I just go a little bit further so that I can see the line. My max was at 10. Maybe I double it and go to 20. I think it was pretty close to crossing, so maybe I'll only go up to 15. And if I'm right, I'm right. If I'm wrong, I'll change it again. There you go. Perfect. That's a great little graph. Let's put that on our picture. Something like that. Okay. Something like that. And maybe let's find some points. Okay. I made my little sketch. It's not a very straight line, but that's okay. Let's find the y-intercept. That's a value of 0. Value of x equals 0, 12. Let's find the x-intercept. Second calc 0. So 2. Left bound. Yeah, I'm to the left right now. Got to move over a big ways. I'll hit enter there. Am I to the right of it? No. I'll go struggle all the way till I'm there. All right, good. Enter and make a guess. Well, I'm already right there. Good. 6. Okay. Probably didn't need to find those, but that's okay. Makes my sketch a little bit nicer. Hey, it says we graphed it. Great. Determine the value of h of 5. Well, what that means is an x value of 5. Right? I'm inputting 5. I can do that. Second calc value x equals 5. It's t, right? The actual function notation on my paper is t, but my calculator only deals with x's. And there it is. H of 5 equals 2. And I could actually plot that, right, on my graph. That is the point 5, 2. Okay. It says write in words the meaning of h of 5. Well, my input was 5. That was hours. So 5 hours have gone by, and my output is supposed to be height. So what it says is after 5 hours of burning this candle, it would have a height of 2 centimeters. I won't write that down. I said it out loud. After 5 hours of burning, this candle has a height of 2 centimeters. Okay, D. So yeah, okay, I said something. I won't write it down. Evaluate the following and explain their significance. Same thing. I'll find them. Okay, we'll actually find these. And then we'll just talk about their significance. I won't write it down. Maybe you could. Okay, h of 0. Again, that's an input. Second calc value, x is 0. And you might be saying, oh, we already found this, right? There's a name for this. It's the y-intercept. The output is 12. So what is the significance? Well, that is 0 time has passed. That's the starting height of my candle. This was a 12 centimeter high candle before you've burned it at all. That's my starting point. That's my original height. Okay. H of 6. Well, let's find that. Second calc value, and I'm inputting 6. And you might also say, oh, maybe this is familiar. Oh yeah, that was the x-intercept. I found that differently, but I already knew that point. That's when I have a height of 0. So maybe I will write something. Okay, h of 0, that's my starting height or starting point. Okay, and h of 6 equals 0. That's when this thing is burnt out. Okay, that's my ending. That's when there is no more candle left to burn. That would be the significance. H of 8. All right, input of 8, second calc value. And it's not even on my screen. Okay, it says x equals 8, y equals -4. Well, that's down here. Okay, kind of by where this calc button is, right? That's where that point would be. So if you're on one of the newer calculators, it'll tell you that point. If you're on one of the older models or just an older operating system, your calculator won't tell you a point unless it's on your window. So if you keep getting an error, it's because your window doesn't show that point. So the newer ones, you might get lucky. The older ones, we would have had it extended our window. But I don't care about this point. This point is below the x-axis. It's telling me I have a negative height. Well, it's a candle. Once it's burnt out, it's burnt out. So all of these points are kind of irrelevant, okay? What is their significance? This has no significance because the candle's already burnt out. Once I get to that ending, once I get to 6 hours, I'm done, okay? I really don't care about talking about it anymore. Let's move on. E, how long will it take for the candle to burn down to a height of 7 centimeters? So what that is suggesting is you have, okay, an H of T value equal to 7, or a Y value in my calculator equal to 7. Well, there's only one place to enter a Y equals on my calculator, the Y equals button. Go down to Y2, type in a 7, head back to my graph. There it is. I want to know that point. I want to know where they cross. Second calc, I can press 5 or I could scroll down. I'm finding an intersect. Or in the first curve, yeah, I'm on the diagonal one. Second curve, yeah, it jumped. Now I'm on the horizontal one. And now make a guess. I make a fairly good guess. X equals 2.5, Y equals 7. Okay, so your answer for that one, X equals 2.5. And I can see that on my graph. All right, last little part of this, it says, suggest an appropriate domain and range for the function. Well, the equation, okay, and what I see on my graph, that line goes on forever. I would say your domain, X element of the rail, your range, Y element of the rail. But I'm not dealing with just that relation. My function is specifically the candle. And how would I talk about the candle? So, domain. It's not X, it's T, such that. And really, the only T's that I care about are 0, the start, till 6, when it ends. 0, less than or equal to T, less than or equal to 6. For T is an element of the real. Between 0 and 6, those are the only two I care about. Okay, and range, well, that would be H of T, such that my range goes between 0. I can't be lower than 0. Once it's burnt out, it's burnt out. And I started at 12. So I go between 0 and 12. 0 is less than or equal to H of T. It's less than or equal to 12 for H of T, element of the real. Okay. Yes, the actual equation on my calculator, that thing goes on and on forever. Based on my context, this would be an appropriate domain and range to talk about. These are the numbers that I actually care about in between these things. And that's it. So again, we did that. We did those same questions when it was just an equation. Now we can talk about them similarly with function notation. Okay, and that's it. So here's your homework on a couple pages, 472, 1, 2AB4, and then jump to 479 and do question 3. And you also have a check for understanding today that you can get to. And yeah, that's it. That's another one in the books. And now we are done with relations and functions. Okay, like I said at the start of the video, little review tomorrow, and then the unit exam summative assessment gets posted. It'll be a Google form, 20 questions. Get it done Friday, right? It's a PD day for staff. Maybe you guys do it on Friday or over the weekend whenever you have time. And then we'll be starting a new unit on Tuesday after the long weekend. For today, get the homework done. There's a check for understanding today. Get that done. Send me a question in the form. Send me an email. Set up a one-on-one appointment. All of that. Smash the like button. Hit subscribe. Stay tuned for a contest that maybe I'll ever do or maybe I won't do. Who knows? And yeah, see you guys again tomorrow.